Hello and Assalamualaikum everyone. Today I'll be presenting about our project titled Age Prediction from Facial Features using MATLAB. So this is our group member. I'm Sumaya binti Ahmad Sadadi and my friends Saktival and Sharon Kumar. Let's begin with the background of the problem. Age estimation is often needed in modern systems, but many of the available solutions are built on deep learning models. These systems are powerful, but they come with high requirements, which large training datasets, long training times, and expensive hardware. On the other hand, simpler systems that do not rely on machine learning are less common, even though they may be suitable for smaller projects or real-time application on limited device. The main problem we aim to address is there is lack of lightweight and interpretable systems that can estimate age groups from facial features without depending on complex AI models. This creates a gap for simpler, rule-based methods that are easier to develop and understand, especially for small-scale use or educational environments. To address this problem, our project has three main objectives. First, to extract and analyze wrinkle-related features from the eye region as a basis of estimating age. Second, to apply classical image processing techniques such as filtering, edge detection, and thresholding using MATLAB. And third, to design and implement a simple rule-based decision method that classifies age into predefined age groups such as young, middle-aged, and elderly. Now, let's move on to the methodology. This flowchart outlines the main steps we followed in our project. We begin with the start point, where the user selects a mode, either capturing a real-time image through a camera or uploading an existing image. This is shown in the mode selection step. Next, we move to image acquisition. Here, the image is converted to grayscale to simplify processing. Then we add salt and pepper noise to simulate real-world conditions, apply a median filter to reduce noise, and enhance the image using histogram enhancement for better contrast. After that, we proceed to eye region detection. If available, we use a cascade object detector to automatically detect the eyes. If detection fails, we apply a fallback method by selecting a fixed region of the image where the eyes are usually located. Once we have the eye region, we move to wrinkle feature extraction. This step involves resizing and smoothing the eye area, applying thresholding and morphological operations, detecting age using the Kenny method, and finally calculating wrinkle density. With the wrinkle data, we then perform age estimation. This is done through a rule-based classification where we map wrinkle density values to predefined age groups such as young, middle-aged, or elderly. Lastly, in the display result steps, the system shows the estimated age group, wrinkle score, and other processing outputs such as filter and age detected image. This completes the entire process from input to output using a clear and interpretable method without the need for machine learning. Now, let me briefly explain how the system works based on the flowchart. First, users can either take a photo using a webcam or upload an image through our simple interface. The image is then converted to grayscale to make processing is easier. We enhance the image using histogram equalization to bring out more details. Next, we add artificial salt and pepper noise to simulate real-world imperfections, and then we clean it using a median filter. After that, the system tries to detect the region using a built-in eye detector. If it doesn't work, we use fixed position based on where the eyes usually are on the face. The eye region is resized and smoothed using a Gaussian filter, which helps make wrinkles more visible. Then we use thresholding and morphology techniques to highlight wrinkle lines, following by canny age detection to clearly detect the wrinkles. We calculate wrinkle density by comparing the number of each pixels to the size of the eye area. Based on this wrinkle density, we use a rule-based method to estimate the person's age group, for example, under 20, 20 to 30, 30 to 45, or above 45. Finally, the system shows the original image, the the process steps, the wrinkle score, and the predicted age group, all through the graphical interface.
Okay, now I will be explain about the team contribution for our program code. Okay, my team member Shaktive is a create age predict functions, and for myself, I create a real time and upload image mode and their functions. And the last one is a Sumaya create design a user interface based on our program code. Okay, now I will explain about the program code. Our which title is the age predict from the facial features. First one is the function of the age graphical user interface, and the green color is our command of the code, and the red color is our explanation of the code. The explanation is to create a custom graphical user interface window with a specific size, title, and a background color. And the second one is that we also add the gradient background, which means generate a smooth gradient background to make the graphic user interface look a modern. And also we have a mode selection at drop down, like user can use choose between the user using a webcam real time or the uploading an image. And also we can listed the camera dynamically, example the internal or external camera. And the next one is the camera selection drop down, shows a live camera image and a step by step process the image for better understanding. Okay, next line of a code is the button style. Buttons allow to user interact, such as start webcam, capture image, or upload the image. And also we add the line of processing output access, shows a live camera image step by step process the image for the better understanding. Okay, next line of a code is we include the mode can change the real time or upload. We use the function of a mode change, and also we use the if else method to choose the upload or the real time. And the display the final result estimated age and the wrinkle density after the image analysis. Also we can add the initialize the webcam start capturing live a video and the show the live image in the graphical user interface. This type of a code we just capture the image, and also we set up the all image of the type of the image, example the jpeg, jpj, and png, and etc. And also it will be read the uploaded image and send it for the processing and display the result based on this code. And also we proceed to display the capture and apply the enhancement and the restoration to prepare the image for the wrinkle analysis to display the result. Okay, in this code, I will be explaining about the calculating the wrinkle density, which mean the wrinkle density is under the 62. It mean the age range is a category as under 20, and under the 70 it will be age range category as a 20 to 30, and the wrinkle density is a 90 below. It will be category as a 32 40. Otherwise the wrinkle density is the other than that it will be category as the 45 plus. And the second was the clear result. If the it will be reset all output to default for the new test. If user click the clear button. Okay, now I will be explaining about the image processing method which used in our code. The first one is a image enhancement. We use the method gray level transformation and histogram equalizations. This is a code used in our system. And the second one is the image restoration. The method we use is the noise models and the filtering to remove the noise and the median filter and the code and the spatial filtering. The third one is a spatial filtering, neighborhood operation, and a smoothing. That means the conversion and the edge detection. That is a canny, and the code. And the fourth one is image segmentation, the thresholding, adaptive, and edge detection, and that's coding. And the sixth one is image morphology, morphological opening the clean edges. And the last one is a feature extraction and a shape representation, wrinkle edge counting, region description, and that's code. Okay, now I will be explaining about the output of a main interface, which mean the this is our interface of our system, the edge prediction and the from the facial features, and each of the button have the functions and the explanation of the buttons. Okay, the first one is the real time and upload mode. User can be change the real time mode or upload mode, and also we can choose the camera, internal or external. Example, internal mean we use the camera of the PC, or external camera like a USB cam or wireless cam. And the third one is the start camera button for real time mode, and capture the button for the real time mode, and upload the image for the upload image mode, and the clear button to clear all the functions such as real time and image uploader function mode. And the third fourth one is display the real time face now image uploader, which mean when we use the real time mode we can see the our face camera face in our display, and which mean using upload image we can upload the image after we can see the image in a display. And the third one is after the image uploader or real time face camera, after the capture we just display the original grayscale salt pepper noise restore and eye region image in the display of the graph. And the last one is display the result based on the wrinkle region and the function of salt pepper grayscale and restore. It will be display the age, estimated age, and the wrinkle density in the result panel. Okay, this is an example of the output which we use the real-time capture mode. Okay, in the real-time mode, when the user click the start button and the camera screen will be displayed in the our graph, and after clicking the capture photo, it's been taken and processed through the several steps. That means the display the original image, converting it to the grayscale, applying the salt and pepper noise, and restoring the image and extracting the eye region. This process image are then used with the image processing technique to estimate and display the user age and the wrinkle density in the result panel. Okay, this is our next output, which in the upload image mode. When the user click the upload image, then selected the image undergoes a sequence of the processing steps, and they include the display original image, converting it to the grayscale, and applying the salt and the pepper noise, and restoring the image, and extracting the eye region based on the process stages. Image processing technique are applied to estimate and display the user age and the wrinkle density. It will be in the our result panel. That's all for me. Thank you.
To wrap up our presentation, here is what we have learned from this project, along with some advantages and challenges we faced during development. First, in terms of what we have learned, we explored how facial features, especially wrinkles around the eyes, can be processed using classical image processing in MATLAB. We learned to apply techniques like grayscale conversion, histogram enhancement, noise removal, and edge detection By combining these steps into a rule-based systems, we gain valuable insight into how basic image processing can solve real-world problems. Next, let's talk about the advantages and disadvantages of our system. One of the biggest advantages is that it's simple, lightweight, and doesn't require machine learning or large datasets. It's easy to understand and works smoothly with a user-friendly GUI. However, the system does have some limitations. For example, the accuracy can be affected by lighting, image quality, or individual facial differences. And because we use fixed threshold rules, the system is not very flexible or adaptive. Finally, we face a few constraints during the project. One of the main challenge was inconsistent eye detection. Sometimes the system could not align the eyes correctly or detect them at all. We also had a small number of test images, which made it harder to make the system more general. On top of that, we had to manually adjust the wrinkle threshold to get better results, and this process was time consuming and less accurate compared to automatic methods. Despite this challenge, the project helped us better understand how classical image processing works and its potential in practical applications.
For our references, we just go through the YouTube video, which the real-time age and gender prediction using the deep learning videos. And the second one is the MATLAB project code. Is be the using a image processing method to do the age and gender prediction code. And the third one is the GitHub. We're using a GitHub for gender and age detection. I think that's all from our group. Thank you. Okay, for now let's proceed to our demonstrate the system by our group member Shaktivel. Thank you.
So hi sir, my name is Shakir Khannan. So I'm gonna present the project we did, which is titled Age Prediction Using Facial Features. So I'm just gonna go through the code real quick. I hope that my friend has presented and explained the coding detailed through PowerPoints. So this is for the GUI part, and then this one's for the cameras. And then these are the buttons for the GUIs. And then this one is access, which is known as allocated parts for the output side. We usually place the outputs at the output window. And then this one's for the functions. This one's for start camera function, capture image function, upload image functions. And then this one's for the output part. So this one would be considered as the main function lah, I would tell main function, which is wrinkle density. And then this one's for clear result button lah, the functions for clear result button. I'm gonna run the project now. So this is our GUI. So we have two modes. The first one is real time, and then the other one is upload image. So I'm gonna go for real time first. So the output is estimated age 20 to 30, then wrinkle density is 76 normalized. So we have these several outputs. So the first one is going to show you the original, and then it's going to convert it to grayscale, and then to the salt and pepper, and then finally restore it back. So once restored, it's going to separate out the eye regions for easier calculation for wrinkle density lah. So this one's for real time. So next one is upload image. So before that, we're gonna clear and then choose upload image. I'm gonna choose few pictures to prove that our project is really working. So, for example, for this, the estimated age is 20 to 30. Still can be considered, I guess. But as I said earlier, it's gonna go through this few process and then separate out the eye region for easier calculation of a wrinkle density lah. So I'm gonna show you a few other examples. For 45 plus, eye wrinkle density is 106.93. And then this one, 30 to 45, the eye region. And then this one, 45 plus. I'm gonna show you here, 20 to 30 still can be considered. And him, maybe 30 to 45. And this aunt, maybe 30 to 45 also lah. So I guess I have shown you both modes that we have created for this part. So I guess that's all from me. Thank you.